Hi, so for today we're going to solve some derivatives. This is an exercise for our lecture, okay, for our previous lecture for solving the derivative of a certain polynomial function. So let's try. So for our number one, we have y is equals to 4x raised to 5 minus 3x raised to 4 plus 2x cubed minus x plus 100. So we can find the derivative of this by simply applying the power formula. So 5 times 4x raised to 5 minus 1 minus 4 times 3 raised x raised to 4 minus 1 plus 3 times 2x raised to 3 minus 1. Okay? And minus 1 because the derivative of x is negative 1. So in this case, we have a minus x, so we have negative 1. Then the derivative of constant should be 0. So evaluating the derivative of that, we have 20x raised to 4 minus 12x cubed plus 6x squared minus 1. And that should be our derivative. So pretty easy, right? Because it's only power formula. Okay, so let's try another one. Let me just insert pages here so that later on we have a space for solving problems. So that is for our number one. For our number two, okay, so we have here number two. Find the derivative of y is equals to 3w squared minus 4 multiplied by 3w squared plus 4. So let us take note that this function is, we can apply product, or simply we can apply FOIL formula in order to simplify this function. Okay, but if we wish to use the rules for finding the derivative, let's say the product rule. So again, we're going to copy first this and then multiply it by the derivative of this, plus copy this and multiply it to the derivative of this. Okay, so applying product rule, we have 3w squared minus 4 times the derivative of this. We can get it directly. This is simply power rule. 6w plus the derivative of constant is 0, so 6w plus copy the second term, 3w squared plus 4, multiply it by the derivative of this, which is actually 6w also. So if we're going to simplify that, if we're going to simplify, y is equals to 6w, that is 18w cubed, minus 24w plus 18w cubed plus 24w. So as we can see here, this 24w and negative 24w plus 24w. So as you can see here, negative 24w is cancelled by plus 24w. So 18w cubed plus 18w cubed, that leads us to 36w cubed. Okay? So that is our derivative. Okay? Or in other words, if in the very beginning we wish to find the product of these two, so that would be, let's say, alternative solution. Okay, so y is equals to, performing FOIL in this, 3w squared times 3w squared, that should be 9w raised to 4. Then FOIL first, outer is 3w squared times 4, that is plus 12w squared, and inner negative 4 times 3w squared, that should be negative 12w squared. Okay, and lastly, the last, negative 4 times 4, that should be 16. Or, oops, that should be negative 16. Okay, so simplifying this, we have y is equals to 9w raised to 4. This would cancel, and we are left with 9 times w raised to 4 minus 16. So if we wish to get a derivative by power formula, okay, power rule, so 9 times 4 is 36w cubed, and the derivative of this constant should be 0. So we still arrive at the same answer. Okay, so for our number 3, we have y is equals to t squared plus, oops, minus 60 plus 9 divided by t squared minus 5t plus 6. So, you may be eager to say, oh, we can use the quotient, okay, product or the derivative of a quotient. But if we will look at it carefully, the given function can be simplified as by factoring t minus 3 times t minus 3. It should be divided by t minus 2 times t minus 3. Okay? So that we can cancel this t minus 3 from the numerator and the denominator, so that we are left with, oops, I'm so sorry, this should be still y because we are trying to simplify first the given function. So that should be t minus 3 divided by t minus 2. So, from here, we can apply the quotient rule. Okay, again, the quotient rule is low derivative of high multiplied by the derivative of I minus high, the derivative of low or the denominator divided by low or the denominator squaring the denominator. Okay, so y prime is low, copy the low, which is the denominator, t minus 2, then derivative, the numerator, derivative of t is 1, derivative of negative 3 is 0. So minus high, t minus 3 times the derivative of low, which is still 1, because the derivative of t is 1, derivative of constant negative 2 is 0. Oops. And then, we're going to square the denominator, t minus 2 squared. Okay? Simplifying this, we have t minus 2 minus t plus 3. Okay? So, t minus 2 squared. So, if we're going to simplify this, we have t minus t, that should be 0. And negative 2 plus 3, that should be 1 over t minus 2 squared. And this should be our final answer. Let me just box that. Okay? So for our fourth example, we have here w, okay, t plus 1 times t squared minus 1 divided by t squared minus 2t plus 1. So here's the thing again. If we wish to get the derivative of the function w prime, we should be able first to simplify the function. So it would help us to easily get the derivative. So t squared minus 1 is equal to t plus 1 times t minus 1. Okay? So if we're going to factor out this denominator, it should be, the given should be t squared plus 2t plus 1. So it should be t plus 1 times t plus 1. Okay? So that, if we're going to look at it, this will cancel, and we are left simply with this t minus 1. So if we do not simplify the function and find the derivative of this using our rule, we may still arrive at the same answer, okay, at the same derivative, but that would take us longer time. So whenever we are given a function and we can simplify and see to it that we should simplify it. So simply our w is t minus 1. So in order to get the derivative of this, simply the derivative of t, okay, or dw over dt, so that should be 1. The derivative of constant is 0. Okay, so for our number 5, oops, number 5, so find the derivative of y is equals to x plus 1 plus x minus 1 over x. Okay, so we need to find the derivative of this dy over dx. As you can see, this is a sum formula, by addition. So in order to get a derivative of this, we can have this formula dy over dx of this x plus 1. We can distribute the dy over dx plus the dy over dx of x minus 1 over x. Okay, this is 1. So if we're going to get a derivative of that, our first term is a quotient. Okay, so low derivative of the numerator, that is 1, minus high, that is x. The derivative of low is 1, divided by square of the denominator. That should be x plus 1 squared. Plus, again, the other term is x minus 1 over x. We will be using again the quotient rule for that in order to get the derivative of that. So we have dy over dx low x times derivative of the numerator, which is 1, minus high x minus 1 times the derivative of the denominator, that is 1, divided by x squared. So if we wish to simplify this, okay, well, of course, we should simplify. That is x plus 1 minus x divided by x plus 1 squared. And on the other side, we have x minus x plus 1 over x squared. So as you can see, x here will cancel. Okay, x minus x is 0. Okay, so y prime is simply 1 over x plus 1 squared plus 1 over x squared. Okay, that's the derivative. But if we wish to simplify this, we can have y prime by cross multiplying x squared plus x plus 1 squared divided by x plus 1 squared times x squared. Okay, so we can simplify this x squared plus 2x plus 1 divided by x squared times x squared plus 2x plus 1 also. So you can see here that we cannot cancel these two because this is addition and we cannot simplify this. So we have x squared plus x squared, 2x squared plus 2x plus 1 all over what? X raised to the fourth plus 2x cubed plus x squared. And that should be our simplified answer. Okay? So what number are we? So number 5. So let's proceed to number 6. By the way, I don't think if we have 10 or 9 problems here. So our next example will be this function for x cubed minus x raised to negative 2 plus 1 raised to 4. So we will be using chain rule here, whereas we're going to assign the inner function as our u. So our u is 4x cubed minus x raised to negative 2 plus 1. Okay, that is our u. So if we're going to go back in our function, u raised to 4. Okay, so if we're going to get the derivative of y with respect to u, we shall get 4u cubed. Okay, so we have solved for the dy over du. Now let's proceed with dy over du over dx. So our du over dx is simply the derivative of this. So we have here 12x squared plus 2x raised to 3, and the derivative of this constant is 0. So 2x raised to negative 3, because negative 1 times negative 2 by power formula, that should be positive 2 times x. Well, we're going to minus or subtract 1 here, so that negative 2 minus 1 is negative 3. Okay? So simplifying our function here, uh, we have this function or the derivative of u with respect to x. Then we're going to apply the formula dy over du, which is here. So our dy over dx is equal to du of dy over du. That is our 4u cubed. 4u cubed multiplied by the du over dx, that is 12x squared plus 2x raised to negative 3. So 4 times what is our u cubed or our u? This is our u. So 4x cubed minus x raised to negative 2 plus 1. Multiplied it by, let's factor out 2 here. So 2 times 6x squared plus 2 over x cubed. Okay, so that if we're going to simplify that, we'll be arriving at the answer. Okay, we can simplify that. 8 times 4x cubed minus 1 over x squared plus 1 times 6x squared plus 2 over x cubed. And that should be our final answer for the derivative. Okay, so let's move on to another number. Applying chain rule. I think this is number 7. So we have y is equals to the square root of 3t squared minus 2t plus 1 multiplied it by t squared minus 1. So find the dy over dt of this function, the derivative of y with respect to t, or in other words, dy prime. Okay, so we need to use again the dy over du, okay, multiplied by du over, in this case, dt. This is still chain rule. Okay, choosing u as our inside function, that is 3 plus 3t squared, 3t squared minus 2t plus 1 times t squared minus 1. Okay, if we wish to get the derivative of y with respect to u, so our given could be written as this. So since this is now u, this is square root of u. Okay? So if we wish to get the dy over du, that is our goal to get this. So dy over du is simply, by chain rule, 1/2 u. This is raised to 1/2. Okay? So 1/2 by power rule times u raised to 1/2 minus 1. Okay? So that would be 1/2 u raised to negative 1/2. So that is our dy over du. Now, we will also find the du over dt. Okay? So the derivative of u with respect to t. And this is our function now. So we're going to get a derivative of that. So by product rule, we can get a derivative of that Okay? So copy the first, 3t squared minus 2t plus 1. Multiply it by the derivative of the second, that is 2t, plus copy the second one, t squared minus 1. Multiply it by the derivative of the first one, 6t minus 2. The derivative of 1 is 0. So simplifying that, we have 6t squared minus, or 6t cube. Let me just erase that so that you will not be confused. I'm so sorry. 2t times 3t squared, that should be 6t cube. Negative 2t times 2t, that should be 4t squared plus 2t. Okay, plus foil. We have to foil this first. 6t cube, the outer. Okay, t squared times negative 2, that is negative t squared. Negative 2t squared. First, then outer, then inner, that is negative 6t, then last. Our last here is negative 2 times negative 1, so plus 2. Simplifying, we have 6t cubed minus 4t squared plus 2t plus 6t cubed minus 2t squared minus 60 plus 2. So simplifying, 60 cubed, combine like terms, 60 cubed, that should be 12t cubed, t squared, negative 40 squared minus 2t squared, that should be negative 6t squared. So 2t minus 60, that should be negative 40. So this is the constant, so plus 2. I hope we're getting the correct answer. Okay, so that is our du over t. Okay, now the derivative of y with respect to t is again dy over du times du over dt. So our dy over du is 1 half u raised to negative 1 half. Multiply it by 12t cubed minus 6t squared minus 4t plus 2. Okay, so our u again, we could go back and substitute u. So 3t squared minus 2t plus 1 times t squared minus 1. So that should be 1 over 2 times the square root. I have bring down the du to make this negative 1 half a positive 1 half. So that is 3t squared minus 2t plus 1 times t squared minus 1. That should be multiplied by 12t cubed minus 6t squared minus 4t plus 2. So if we're going to multiply that, again, rewriting that, so we can factor out, just rewrite this so that you will not be confused. Okay? So divided by 2 times the square root of 3t squared minus 2t plus 1 times t squared minus 1. Okay? So we can factor out 2 here, so that 2, 2 is equals to times 6t cubed minus 3t squared minus 2t plus 1, okay, divided by 2, so that 2 will cancel out. So we have 3t squared minus 2t plus 1 times t squared minus 1. Okay? So our final answer, again, should be 6t cubed minus 3t squared minus 2t plus 1 divided by the square root of the denominator. 3t squared minus 2t plus 1 t squared minus 1. Okay? We wish to rationalize, you can do it also. Okay? But for now, this should be our answer. 6t t cubed minus 3t squared minus 2t plus 1 over square root of 3t squared minus 2t plus 1 times t squared minus 1. So for our example 8, okay? So for our example number 8, we have here y is equals to 3x plus 2 divided by 2x minus 1 squared. So in this function, we will still be using chain rule. Okay? Again, chain rule is dy over dx since our function here is in terms of x. That is dy over du times du over dx. Again, our u is simply the inside function 3x plus 2 divided by 2x minus 1. So that if we let that u is equals to this, so we can rewrite the function as y is equals to u squared. Okay? And getting the derivative of y with respect to u, that should be 2u. Okay? Now, if we wish to get du over dx, derivative of u with respect to x, we should apply quotient here. So, low d high, low, or the denominator times the derivative of this, which is 3, minus, low d high minus high, copy the numerator, then the derivative of low is 2, divided by 2x minus 1 squared. So the the denominator squared. So our du over dx, if you're going to simplify that, is 6x minus 3 minus 6x, okay, minus 4. So 2 times 3x is 6x, but we apply negative sign, that is negative 6x. 2 times 2 is 4. We apply the negative sign, that is should be negative 4, divided by 2x minus 1 squared. So clearly, we can cancel out this. So negative 3 minus 4 is negative 7 over 2x minus 1 squared. And I think that should be our du over dx. So finally, in order to find dy over dx, we should apply the formula again. dy over du, multiply it by du over dx. Our dy over du is 2u here. Here is our dy over du, 2u. So 2u multiplied by du over dx, that is negative 7 over 2x minus 1 squared. Okay? So back substituting our u, which is 3x plus 2. So we have 2 times 3x plus 2 over 2x minus 1. 2x minus 1. Multiply it by negative 7 over 2x minus 1 squared. So, what are we going to do here is that we can multiply it. So, negative 14 times 3x plus 2 over 2x minus 1 cubed. We can multiply this by numerator to numerator, denominator to denominator. Okay? So, we can have this as our final answer. Okay? Let me just rewrite this legibly. 2x minus 1. Okay? So, we can have this as our final answer. Okay. And another one, for our number 9, we have y is equals to, dealing with square roots again. So this is an easier one problem. X squared of x squared minus 1. Again, our u should be x squared minus 1. And y would now be replaced by square root of u. Okay? Or simply u is raised to 1 half. We can get dy over du, the derivative of y with respect to u, that should be 1 half u raised to 1 half minus 1 is negative 1 half. That should be our dy over du. Again, this is still chain rule. Okay? So, again, we could also get du over dx, of which, oops, I've overrewrite it. So du over dx is simply the derivative of u with respect to x, that is 2x. So that our dy over dx is simply dy over du times du over dx. 1 half u raised to negative 1 half, multiply it by 2x, of which we can see that 2 will cancel. Okay? And back substituting u, wherein our u is x squared minus 1, and eliminating the negative uh, sign of the exponent, we can bring it down. So, x squared minus 1 times x, or simply x over x squared, square root of x squared minus 1. Okay? So, here is our last number. Okay? So, we'll make it 10 so that you will be practiced. So, y is equals to x plus 1 times square root of 2x minus 1. Oh, okay, we can use product rule here. So y prime is simply copy the first term, x plus 1, then get the derivative of this. Applying chain rule, again, 1 half, because 2x minus 1 is also equal to 2x minus 1 raised to 1 half. So 1 half, then uh, 2x minus 1. 1 half minus 1 should be negative 1 half. Multiply by the derivative of the inner function, that is 2. Okay, we can see here that this 2 will cancel. Okay, so plus, we're not yet done. Plus, we copy this and get a derivative of this. Now, we copy the second term, which is 2x minus 1 raised to 1 half. Then, derivative the first product, that is 1. Okay? Simplifying, that is x plus 1 over 2x raised to minus 1 raised to 1 half. I have eliminated the negative sign by bringing this term down. Okay? So, x plus 1, okay, plus simply 2x minus 1 raised to 1 half. Okay, we can simplify this. In other words, we can rewrite this in terms of square root. X plus 1 square root of 2x minus 1 plus square root of 2x minus 1. So by simple addition, we can get the final answer, that is x plus 1. So when we're adding, we're going to multiply this 2. So, and we're going to add this, the multiplication of this by this term. So, plus simply 2x minus 1, because the square root will cancel because of the multiplying. Okay? And then, over by the denominator. Okay? 2x, square root of 2x minus 1. So, we can see here, x plus 1 plus 2x minus 1. So, we can see here that 1 and minus 1 will cancel. So, x plus 2x, that is simply 3x over square root of 2x minus 1. And we got already the answer. I hope you enjoy this, and I hope you find this very helpful. So, thank you again for watching my videos. Don't forget to subscribe. Thank you so much, and God bless.